Hello. So today's question again it is on successive disintegration. So nuclei of type A are being produced at a constant rate Q in a nuclear reaction. The unstable nuclei A decay to stable nuclei of type C through intermediate unstable nuclei of type B as shown in the figure. That is A, rate of disintegration is lambda, A gives B and B gives C, and the C which is formed is stable. This is the figure which they are referring to. If lambda A and lambda B are the decay constants of the nuclei A and B respectively, calculate the activity of the sample at time T after the reaction process has started. This question was asked in JAM Geophysics 2012. It is just same as the one which we have done earlier for successive disintegration, just asked in a different way. So see, let Na, Nb and Nc are numbers of nuclei at some time t. Okay, now we know that dNa upon dt, it is equals to rate of production of A minus rate of decay of A. So rate of formation of A, it is given. Nuclei of type A are being produced at a constant rate Q. That is nothing but rate of production of A. So dNa upon dt we can write as rate of production of A, that is Q, minus rate of decay of A. Decay rate we know that it is given by lambda A and A. Okay, so this equation is very important. So you should know dNa upon dt, it is equals to rate of formation minus rate of decay. Once you have done this, I will shift this lambda Na to this side. So I will get dNa upon dt plus lambda A and A, it is equals to Q. Now this is again first order differential equation of the type dy by dx plus py equals to Q. So in such case, solution is given by finding out integrating factor. Integrating factor, it is equals to e raised to integration of p dx. So हम लोग यहाँ पे integrating factor find out करेंगे. Integrating factor will be equals to e raised to integration of p. p क्या है? Lambda a. So lambda a dt, instead of x here we have t. So you will get e raised to lambda a. Okay. Lambda a into t, that is our integrating factor, and solution of such kind of equation, it is given by y into integrating factor, it is equals to integration of q into integrating factor dx plus c. So हम लोग ये formula apply करेंगे for finding out solution. So y into integrating factor, so we will have, instead of y we have na into integrating factor, it is equals to integration of q into integrating factor. Integrating factor is e raised to lambda at dt plus c. So here we will get q is constant, e raised to lambda at का integration e raised to lambda at upon lambda a and plus c. e raised to lambda at का integration, it will be e raised to lambda at upon lambda a. q तो constant है, so q I took outside, plus c. So this is na e raised to lambda at, it is equals to this. Now what we will do, we will divide by e raised to lambda at to the whole equation. So this will get cancelled, this will get cancelled, and here we will get e raised to minus lambda at. Okay, so what I will get, na, it is equals to q upon lambda a plus c e raised to minus lambda at. I have simply divided the whole thing by e raised to minus lambda at, e raised to lambda at, that is it. Okay, abhi what we have to do, we have to find out the value of this constant. So constant agar find out karna hai, to we always put initial condition. So initially there was no atom A, it started forming. So if we consider the initial time, that means at t equals to 0, it was just trying to A started producing, so it was number of atoms in A were not there, so Na equals to 0. So we will substitute this values here. So Na equals to 0 equals to q upon Na q upon lambda a plus c e raised to t की वैल्यू 0 है, so e raised to 0, e raised to 0 is 1. So what I will get, c equals to, I will shift this to this side, minus q upon lambda a. So this is the value of constant. Now I will substitute this value of constant. So here what equation I'm getting, dnb upon dt plus lambda b nb, it is equals to q into 1 minus e raised to minus lambda at. Now again here this is differential equation of the first order. So अभी हम लोगों ने पहले के लिए जैसा प्रोसीजर किया था same we are going to do. So first we will find out integrating factor. So here integrating factor, it will be e raised to integration of p dt. So that is lambda b, e raised to lambda b t, or solution is y, that is nb multiplied by integrating factor integration of q. q is q into 1 minus e raised to minus lambda at. इसको multiply करेंगे with e raised to with lambda t, that is integrating factor, plus c. Now we will solve this. So we will get q, then integration of, अगर मैं bracket solve करती हूँ तो, so e raised to lambda bt into 1, so I will get e raised to lambda bt minus e raised to minus lambda at into e raised to minus lambda bt plus c, this multiplied by dt. Okay, so next step में I will find out the integration of this. So what I will get, q, so nb e raised to lambda bt, it is equals to q common integration of e raised to lambda bt, it will be e raised to lambda bt upon lambda b. Same integration of e raised to minus lambda at or plus lambda bt है, so I can write that e raised to lambda b minus lambda at, right? So here I will get e raised to lambda b minus lambda a upon lambda b minus lambda a plus c. So in the next step what I can do, nb equals to, I can divide by e raised to lambda bt, the same procedure which I have done I am doing for this also. Okay, so nb equals to q, here if I divide this I will get just simply 1 by lambda b. Here I will get e raised to minus lambda at upon lambda b minus lambda a, because e raised to lambda bt got cancelled, and plus c को भी divide करेंगे, so I will get e raised to minus lambda bt. Okay, now we have to find out the value of this constant. So at t equals to 0, what we have, nb equals to 0, nb तो फॉर्म ही नहीं हुआ था, so nb equals to 0 equals to q 1 upon lambda b minus e raised to this, e raised to 0 is 1 upon lambda b minus lambda a plus c. So c का वैल्यू क्या आएगा, c will be minus q, just I will shift this term to this side, c equals to minus q 1 upon lambda b minus 1 upon lambda b minus lambda a. I am getting this, right? So if I will substitute this value here again, so I will get nb equals to q 1 upon lambda b minus e raised to minus lambda at upon lambda b minus lambda a, और c की वैल्यू, so minus q 1 upon lambda b minus 1 upon lambda b minus lambda a into e raised to minus lambda bt. I got this value. Now at time tau, because in the numerical they have asked at time tau what, so at time tau na equals to, हम लोगों ने फॉर्म फाइंड आउट किया है, na equals to q upon lambda a. So I will substitute tau there, so na equals to q upon lambda a, q upon lambda a 1 minus e raised to minus lambda a t. This is the value of na. So t की जगह पे I will substitute tau. here I just have to write tau instead of t, and nb equals to q 1 upon lambda b minus e raised to minus lambda a tau. t की जगह पे we are simply substituting tau lambda b minus lambda a minus q 1 upon lambda b minus 1 upon lambda b minus lambda a e raised to minus lambda b tau. So this we are getting Na and Nb at tau. So simply जो equations मिला था Na का Nb का, उसमें हम लोगों ने we replace small t by tau. That's it. Now what we have to find out in the numerical, we have to find out activity of the sample. So activity of sample at t equals to tau find out करना है. So what is the formula for that activity? It is given by rate of decay of A plus rate of decay of B. तो हम लोगों को Na की वैल्यू पता है, Nb we know at tau, Na and Nb we know, उसको simply lambda A से multiply करो, lambda B से multiply करो, and you will get a very big equation. Lambda A multiplied by this, lambda B multiplied by this, so you will get activity of the sample. So here I can write lambda A, lambda